Hello everyone, welcome back. Today we're going to be looking at Pascal's triangle, which is the next part in the binomial theorem, which is one of the topics in the Advanced Higher Maths course. So let's get into it. So if you focus your eyes to the centre where there's a pyramid of numbers, that's actually Pascal's triangle. Now you're probably thinking, why do we need Pascal's triangle? Or what even is Pascal's triangle? Well, I'll tell you now. That's going to be my new phrase from now on. So if we look over to the top right, we have x plus y to the power of n. Okay, so for Pascal's triangle, if we have specifically x plus y to the power of n, we can find the coefficients of the terms, right, by using Pascal's triangle. So I'll explain it a bit more now. Say we have x plus y cubed. So we go down to the third row of Pascal's triangle, and we see these numbers, 1, 3, 3, 1. Now you're probably thinking, well, how did we get to these numbers? It seems like an odd jumble of just digits. So what happens is that the next number is the result of the upper two numbers added together. So I'll show you. So say, for instance, 4. How did we get to 4? Well, we added 3 and 1 together to get 4. And for the sides, they're always 1, okay? And we start at the top with just 1, and then there's actually zeros here, right? Dodgy zeros here. So it's just 0 add 1, that makes 1, and then 0 add 1, that makes 1. And then in the second row, right, so all of these rows are numbered. In the second row here, it's again just 1 on the side. But then, next, the above two, which is these ones from before, we add them together to get 2. And then it goes on and on and on and on forever, okay? So these numbers in row 3 represent the coefficients of x plus y cubed, okay? And you can see it here, where I'll highlight it in green, where you've got 1x cubed plus 3x squared y plus 3xy squared plus 1y squared, which matches these numbers here. Okay, so we actually use Pascal's triangle in the binomial theorem, but I'll explain that in the next video. I've just got to give you the basics here. So let's take a look at this Pascal's triangle. Now this is exactly the same Pascal's triangle. They give exactly the same values, but they are in binomial coefficient forms, right? If you don't know what a binomial coefficient is, I've got a video on it from before. I suggest you watch it, otherwise you won't know what I'm talking about here, okay? So say we have at the bottom nr, that equals n factorial over r factorial times by n minus r factorial, right? So if we take 0, 0, or any number like 3, 3, then after all of the work we get 1. Now 3, 3 is right here, and you'll notice a pattern. So when we go down a row, we increase n by 1. So if we have 0, 0, go down by 1, then we have 1, 0, right? And then you have 2, 0, 3, 0, and so on. And then when we go across a row, we increase r by 1 every time. So at 2, 0, it goes on the right to 2, 1, then to 2, 2. And then it always goes up until r equals n, okay? So if we had, say for instance, 5, 0, that would go along up until 5, 5, right? And then the result of these binomial coefficients are actually just numbers, and those match the numbers on this Pascal's triangle, right? And so I'll show you what these are useful for. So I'll actually write the binomial theorem now, and it's where we've got a notification. It's where r equals 0. Oh, that's a bad colour actually. I'll change that, sorry. So I'll have a Now this may look a bit daunting at first. R equals 0 all the way up until n. of n r of x n minus r and of y r. Right, so that's the binomial theorem, and you will see in this part nr. So for instance, let's say we want to expand x plus y to the power of 5. Well then, we'd be using the binomial coefficients here that go from 5, 0, all the way up to 5, 5 in the formula, right? But I'm not going to teach you about the binomial theorem today. It's just where we're going with this Pascal's triangle. And so the most important thing to take away today is this binomial coefficient, Pascal's triangle, as we'll be using it in the next video. Thank you very much. I hope you've learned something today. Please watch this a few times to get it in your head. The next video should be coming out soon.